Welcome back. We're going to work on the servo motor now and the circuit for it, and then I'm going to show you how to program that. In your kit, you should have something like this. This is called a servo motor, or more specifically, an SG90 servo motor. So the SG stands for soft gear. So there's a little motor in here and a little gearbox that's made out of plastic gears, right? You see that little gear train. They sell other ones that are a little bit stronger, have a little more torque, that are MG, they're metal gear. But these ones are pretty good and they're nice and cheap. They should also come with a little baggie that looks something like this. Basically, these three plastic pieces are the horns, or the pieces that go on the front of the motor, and actually like that you can attach things to, and you could just pop it right on there. It also comes, I'm just going to take all this out. Also comes with two screws. These bigger ones are for mounting, so they go through these holes, and you could like mount them to plastic or whatever you want. This smaller one is what like will lock the servo horn into place. So if you just take a small screwdriver, put the screw in there. Uh, make sure I don't make sure I go in at a 90-degree angle. Get that in there. The great thing about these motors is that it can rotate. Um, Usually they'll rotate 0 to 180 degrees, and they can remember their position. Also, don't do what I'm doing, spin it back and forth. I think that is bad for the motor, but who cares? Um, but you guys only get one of these in your kit. I don't want you to break it. But the good thing about servo motors is they'll rotate 0 to 180 degrees, but they can remember their position. That's super useful for our project because if it's at 0 or 180, if it's at 90, it knows exactly where it is. So that's good. So there's three wires. Just like the LED, you'll have a red and a black wire. So black is ground for -5 volts. Red is +5 volts, so the positive voltage. And then this orangish wire is the signal wire. So instead of two wires on the LED, now you have three, because there's two just for power and then a third one which tells the servo sort of what to do or command it where to go. So the way that we're going to wire up this is, let's grab our wires from our previous circuit. I'll put these back in the baggie because we're not mounting anything for now. Okay. And so pretty self-explanatory, but like I said, I like to use black wire goes to ground. Red wire goes to +5 volts. Just match up the colors. I like to try and stay consistent so it's easy to see what's what. Make sure it's fully in that terminal block. And then you take the yellow wire, and that goes to our orangish wire, right? So if you look at the Arduino now, we've learned before that if you power the Arduino, you can give the Arduino plug it into the ground. The black goes to ground. The red is going to go to +5 volts or 5V on the Arduino. And then our yellow wire, once again, is our digital signal wire. So where is that going to go? On one of the digital PWM ports. And this is specifically important because I can talk a little bit about it later, or if I've already talked about it. But PWM is pulse width modulation. These take a specific signal to control them. So they have to be on one of these ports, but we're going to do that anyway. So let's once again plug it into pin 8. And boom. That's all you have to do to hook this guy up. Now let's jump into the Arduino, and let's jump into the Arduino IDE, and I'll start explaining how to program this thing. All right, welcome back. Now I'm going to show you how to program the servo motor. So to program the servo motor, we're going to do the same thing as we did for the LED. We're going to reference an example and sort of change that around to get what we want. Okay, so once again, we're going to go to File, Example, and then we're going to scroll down until we see. You know what? You're probably not going to have this by default. You might. I'm not sure, but just to make sure, uh, make sure you go to Tools, Manage Libraries first. Might take a second to upload or pop up. Basically, there's tons of different libraries with all these different examples that we could reference, and you don't have all of them by default because they're like always coming out with new ones, and there's tons of them. So let's just make sure you have your the Servo library downloaded. So we're just going to type Servo in the search bar, Servo. Okay, and then it's the second example right here. I have mine installed. It says installed right next to it. If you didn't have it installed, you just press install, this button that's grayed out for me. So I have that. Once you have that installed, then just like before, we're going to go to File, Examples, and we're going to scroll down until we see Servo. And then in the Servo expanded column, we're going to go to Sweep. Okay. So just like before, I'm going to explain everything line by line, and hopefully you guys begin to understand what's going on in the program. So these are all commented. Same thing if you see double forward slash. If you see uh, one forward slash and then a star, that means like start the comments here. And then if you see a star and then forward slash, it means end the comments here. So it's like an easy way to comment out like a whole paragraph instead of doing like two forward slashes for each line. So this is basically just communicating some information to us. Those are notes. The first line we have is this hashtag or pound include, and then these open and close arrows, servo.h. So I explained it a little bit before, but basically what a library is like, think of like, we're not programming for the first time, right? Tons of people have created programs and like super efficient ways to do things, and they've made it open source and free for people to use in their programs. And in order to use all of the things that they created, we just have to include a line to like include the library of all the tools that they made, right? So that's what this line is doing. Basically, it's just saying, hey, for this particular component, use and reference all the library of like functions and tools that other people have made so we can like pull it into our software. So that's all this line is doing. It's saying include this library so we can use the functions created for the servo. Okay, that's the first line. And then the second line, so in this orange lettering here, you see servo, and then you see my servo, and then it's ending with a semicolon. Basically, what this is saying is if you see this servo, my servo, this could be anything you want. You're just naming like you're coming up with a name for the servo you're using. So servo basically says, okay, we're creating a new variable. We have a servo that we need to communicate with. Um, let's name it something. This is just a name variable. You can name it whatever you want. They chose to name it my servo, and then you end the line with the semicolon. So all we've done so far is pull in the library, and then we're saying we're working with the servo, and if we're going to reference it later, let's call it my servo. And then once again, in this program, just like the Blink program, they're creating a variable, like a custom variable, and the data type is int. It's going to be an integer. So int is and then they call a new variable called POS, or I think this means position, and they're initially setting it equal to 0. So more on that in a little bit, but basically just know that there's a new variable that we're going to be talking about, and at first, before the Arduino starts up, that position is going to equal 0. And then also a little bit on like what goes above the void setup. So there's the void setup we talked about, which runs everything once. There's the void loop, which runs everything like forever in a loop. And then sometimes there's information above. I don't know exactly the reason why, like what goes like maybe this could go in void setup, but I sort of just like follow the way that the examples structure all their code, and that's sort of just like how I've been running my code ever since, right? Um, so usually up here, what you're doing is like including libraries, you're defining variables, and then usually in the void setup, you're saying like, um, where on what ports do things belong, things of that nature, right? So that's what they're doing here, right? Void setup is going to run exactly once. What are we doing? We're saying that we've created a variable for our new servo and we've called it my servo. So for the my servo variable, they say dot attach. So this is just like pin mode, right? You're telling the program which port your servo is attached to. That's how you do it for servos. So in the void setup, you have to say whatever your variable for your servo is. So that was my servo dot and then attach, and then you just do open and close parentheses, and inside you put the number of the port that you want to talk to. So in this specific example, they had 9, ours is 8, so we're just going to change that to 8, and then you end it in a semicolon. And that's all that's going on in void setup. Okay. Now for void loop. So let's talk about this. So what's going on here? This looks kind of messy, but I'll try to explain it the best I can. So this is a for loop. A for loop is a super powerful tool commonly used in programming, and just like the void loop that is like the main body of code where everything is going to run forever, a for loop is an additional loop. And basically, all you have to do to use the for loop is you have to say, okay, where does the for loop begin? Where does the for loop end? And then what happens in each cycle of the for loop? So if that's confusing, just stick with me. So the for loop, if you look here, the syntax or the way that you use a for loop is you do for and then you do open and close parentheses. So for open and close parentheses, and then you do like a squiggle bracket, and then if you press enter, it'll automatically make a corresponding close squiggle bracket, and then you type all your code here that you want to go, and then in here there's going to be 3 arguments. So 1 separated by semicolons, not commas. So 1, 2, 3. And that's all that's going on here, right? So I'll explain that. So for, so we're creating a new for loop, and we're saying that the initial position, so where the for loop is going to start, is for when the position of the servo equals 0. The end parameter is when the position of the servo equals 180 degrees. And then what this is doing is saying it's going to add, for each cycle through the for loop, it's going to add 1 degree of rotation for the servo. So we've spoken a little bit about what a servo motor is so far, but basically it's a little motor, and it has like a memory of where its position is, right? So it can rotate 180 degrees. So if this is your servo arm and it's starting at 0, it says, okay, start at 0, and every time you go through this for loop, add 1 degree of rotation. So the first time through the for loop, it's 0. Second time through the for loop, it's 1, then 2, then 3, then 4, then 5, all the way to 180 degrees, right? So we're saying start at 0 degrees, end at 180 degrees, and every time through the cycle, add 1 degree. So each time through the cycle, what's going on? That's what's in this main body of code within the squiggle brackets. So my servo.write, just like my servo.attach, is a function that lives in the servo library that someone else created. So the way that this works is you're like commanding the position of the servo. So so this line starts with my servo. You have to call whatever we named our servo dot write, just like with the LED, we're writing information out. We're telling the servo what to do, and we're telling it to go to the whatever degree the variable position is at. Just stick with me. I'll this will be clear in a second. And then it says delay 15 milliseconds. So if I can't understand a for loop, I go like one by one with each number through the for loop until I understand. So let's do that. Let's say that position equals 0 at first, right? We've defined it up here to be 0. This is the first cycle through the for loop. What's going to happen? The for loop starts when position equals 0. So now we're good to start this for loop because we're in the parameters, we're within the parameters of 0 to 180, right? So when this for loop ends, we're going to add 1 the when this for loop ends, position is going to go from 0 to 1. That's what this line means. We're adding 1 to position with after every cycle of the for loop. So this is going to happen when the for loop ends, right? So this line says write to whatever position is equal to. Right now it's equal to 0, so it's not going to move. And then wait 15 milliseconds. So all that we've done, basically not much has gone on because we haven't iterated through the for loop at all yet. So that's the first cycle. What's the second cycle? Okay, the for loop is over. We're going to add 1 to position. So 0 plus 1 is 1. So now imagine that position is equal to 1. So it's still good to run through this for loop because 1 is between 0 and 180. And it says, okay, now go from 0 and write to the position of 1. Now position is equal to 1, write to 1, and then wait 15 milliseconds. So after that's done, what's going to happen? We've ran through the for loop, so we're going to add 1 to position. Now position equals 2. Okay, we're still within 0 to 180. What happens? It says write the servo to the new position. So that's 2. We bump up by 1 more degree. Wait 15 milliseconds. The for loop ends. We add another 1 degree to position. Now position equals 3. Then 4. Then 5. Then 6. Basically, this means go from 0 to 180 degrees and go 1 degree at a time. And every time you hit that 1 degree, wait 15 milliseconds. So it's going to go from 0 to 1, wait 15 milliseconds. 1 to 2, wait 15 milliseconds. 3, 4, all the way to 180 degrees. Okay, so we've basically established what's going on here with the for loop, right? We're going from 0 to 180 degrees, 1 degree increments, and every time we hit 1 new degree, we're waiting 15 milliseconds. So what happens? So we start at 0. What happens when we get to 180 degrees? So now let's just say we've gone all the way through, and position now equals 180 degrees. So this isn't going to run anymore because it's outside of the parameters that we've set, right? So now what happens? Now it's going to go, so this for loop is done. So now we're going to go to this new for loop. And this is the opposite. So it's going to send it backwards to 0 degrees. So it says if position is somewhere between 180 degrees and 0 degrees, then this is the opposite. We're going to subtract 1 degree. So if we start at 180, it says move position to 180. Cool, we're already at 180. Delay 15 milliseconds. We made it 1 way through the for loop, 1 cycle through. Now subtract 1. Now we're at 179. Right to position to 179. Wait 15 milliseconds. Okay, we've made it through the for loop. Subtract another one. 178, 177, 176. All the way back to 0 degrees. Okay, so this is basically the same thing, just in the opposite direction. Now, once we finish the for loop, oh, this is a void loop, so this is going to run forever. We finish the last line, and we're going to jump back to the beginning, and this is going to all occur like infinitely in a loop. It's like it's a loop within a loop, right? It's going to run forever. It's going to go forward, hit 180 degrees, go back, hit 0. And it's going to do that over and over and over again. Also, a little tip is if you like click next to a bracket, it'll tell you which bracket that corresponds to. So if I click this, so I put my cursor next to this squiggle mark, it's putting a box around this void loop because it's saying this is the open loop that corresponds to this closed bracket. Also, I just want to explain to you there's a difference between, like, if we said position equals 0 and position equals 0, there's a difference, right? This is an important thing to remember. So one equal sign means you're setting something, you're setting the value of something. So that's what we've done up here. We're saying position is equal to 0. So now position, the value of position is 0. This is saying, this is used in like arguments for like a for loop, for example. I know this is just one, but stick with me. Um, so so this is saying if position ever equals 0. So like this could be like this, right? So if position is ever equal to 180 degrees, but instead of, this is the way they have it, is this means greater than or equal to. So that's what the difference is here, right? Sorry if I didn't explain this initially. So for the first one, we're once again setting the value equal to 0. And for the second one, it's like a comparison. We're saying, we're not saying make position equal to 180. We're saying do run the for loop until this is equal to 180 degrees, right? So the difference is one equal sign, you're assigning a value, and the second one is you're using it as like a comparison. So this for loop, this parameter is saying, all right, position, the new value of position is 0. This second parameter is saying we're going to run the for loop all the way up until this is less than, that's what this sign means, less than or equal to 180 degrees. That might be a little confusing. You'll get it more later. But just if that confuses you, just remember that one equal sign sets the value equal to something, and two equal signs, or if the first equal sign is replaced with like a greater than or less than sign, means a comparison. We're running this for loop up until 180 degrees. Okay, so that's all the software explained for this example. Let's go ahead and hit upload, and I'll show you what that looks like in real time. All right, we're gonna upload our script. All right, now check it out. So this is what's supposed to happen. Just like we discussed, the servo is gonna take its time, going one by one, increasing from 0 to 180, hits 180, comes all the way back, and it's gonna loop forever, just like this. Boom. All right, so that's the servo. In the next part, we're gonna talk about the ultrasonic sensor.